Hey, welcome back to the channel. I'm Joe Phillips, Director of Education at Instructing.com, and many of you know Roz. Today I want to talk to you about impractical deadlines. Roz has a deadline every day at about 5 o'clock, and she's not happy. And that is her meal that we know when it's time to eat, that's a deadline. Question that I get from time to time, and unfortunately more often than what I like, is the idea of dealing with impractical deadlines. Have you ever been on a project where your scope is huge, the deadline seems unreasonable? So let's talk about that now. How do you deal with impractical deadlines? An impractical deadline in a predictive environment is always something that we have to take into consideration because the deadline is a constraint. A deadline means we have to be done with all of the work in a predictive environment by a given day. So it's not always reasonable. A constraint is anything that limits your options. So by saying this project has to be done by December 15th is a constraint. You are constrained in your effort, in the options, in the work that you do to get to that specific date. Now let's go back to this idea of a deadline being unreasonable. I mean, unreasonable is unreasonable, but how do you know it's unreasonable? Is it based on your experience? Is it based on past projects or historical information? Is the idea of being unreasonable based on industry standards? Have you done analogous estimating? Where analogous estimating is you're creating analogies between this project and other projects. So again, you have historical information that if project A over here took 6 months to do, and now this project you're on, project B, is very similar, but the demand is to get it done in 3 months or 4 months, that doesn't seem reasonable. It doesn't seem to mesh with the understanding of how long project A took. And this is very similar to project A. So is that unreasonable? Now, another thing to consider with unreasonable being unreasonable is what's called the first time, first use penalty. Imagine the guy that ate the first oyster and somebody had to go first. So they didn't know what it was going to taste like. It was going to be good, if they were going to like it. They have some hot sauce to put on it. I don't know. But the first time, first use penalty is the first time you do anything, you don't know how long or how much or what the experience is going to be like. So if you've never done this type of work before, you've never taken on a project like this, it's very difficult to predict how long it will last. So if you've never done this type of work before, but you have a deadline to get all of this scope done by December 15th, that may be unreasonable. Because you don't know, you don't have relative knowledge. You don't have a clue as to how long it will take. There's a lot of information that is needed to predict how long this project will take. And is that really unreasonable, or is it an arbitrary date? Now, the deadline may have a good reason for existing. It may be there's a market opportunity or a business cycle or some type of a cutoff, like a new operating system you're moving to, or a new regulation. Those are all reasons why you might have a deadline. But is it unreasonable for your scope to be so large to get to a specific date? So we have to have evidence of how do we know it's unreasonable, or you don't know what you don't know. One of the things that we can do when it comes to believing we have an unreasonable deadline is to invest some time in estimating. That we need to estimate how long this project or this work or this endeavor will take. One of the ways that we can do that is called the definitive estimate. The definitive estimate gives us the highest level of confidence in predicting the ability to reach an unreasonable or a reasonable deadline. That we have some insight into how long it will take to get to this point in time or to complete all of this work by that date off in the future. To do the definitive estimate, there are several things you have to have though. First off, we have to have a well-defined and approved set of requirements. We have to have a scope. We have to know exactly what it is that we're trying to achieve in the project. Then that scope, we have to decompose it. We have to break it down to the work breakdown structure. Recall that the work breakdown structure is a visual decomposition of everything that we have to do in the project. So if we're building a house, we would have the house, and then we might say the first floor and the second floor. And then the first floor, we might say the garage, the kitchen, and the living room, and the bedroom, or what have you. All of the different rooms. And then within each room, we could break it down again. The cabinets and the countertops and the appliances and so on. All the way down till we get to the tiniest item that's broken down in the WBS, which is called the work package. The work package then correlates to the activity list, the activities that are needed to make this thing happen, to install the cabinets. So you think about ordering from the vendors and their lead time, actually choosing the cabinets, which if you built a house, you know how much fun and time consuming that can be. And the cabinet tops and the appliances and so on. All of that takes time to make those decisions and to get the materials and to install it and make it happen. So a lot of time just for that one component of your work breakdown structure, of your scope, of your set of requirements. But that's what it takes to get to the definitive estimate. That you have to have all of those things in place to estimate the activity duration, and the sum of that will tell you how long your project is going to take. Now, to get to the definitive estimate, it's going to take a long time. You got to have a lot of information and a lot of resources to help you predict how long each of those activities are going to take. Not to mention putting those activities into a project network diagram so you can see the flow in lead time and lag time and the overlap of different activities to truly predict the total duration of the project. So it's very time consuming just to get to that point in a predictive project, but it's the most accurate. Now, another approach I mentioned a moment ago is to create an analogous estimate. Project A took 6 months. This project is very similar, so it's probably going to take 6 or 7 months just based on the set of requirements that we have now in comparison to what we've done in the past. So we have proven historical information to say that's a reasonable deadline or it's not a reasonable deadline. Now, another approach we can take is called the parametric estimate. In the parametric estimate, we have a parameter for a set of activities to predict how long it would take to do those activities. So for example, very simple example, let's say that we have 1,000 new light fixtures to install on a campus. And we go out with our team and install some light fixtures, and it takes about 4 hours to take down the old light fixture and to install the new light fixture and to test it and to be done. All right, it takes about 4 hours. Well, you might reason, well, then you have 1,000 of them to do, and it's 4 hours per fixture, so that will be 4,000 hours. How many people you have, X amount of hours per day, 8 or whatnot, then they can do 2 a day, and you can extrapolate there how long it would take to do that set of activities. The problem with the parametric estimate, though, is we don't account for the learning curve. The learning curve is the dip that you take when you learn something new. So efficiency often goes down or is not as high as it will be once you've mastered that activity. So it takes 4 hours to install that light fixture for the first 3 or 4, but the people installing it, they're going to develop a rhythm and a cadence and a system to install that more efficiently over time. Because the learning curve, they're going to become more efficient. So what was once the 4 hours now maybe has morphed into 2 hours. But on paper, in our plan and our prediction, we said 2 hours to install or 4 hours to install that fixture. So you don't always know what you don't know until you prove it, until you have experienced the actual install of those fixtures. In any project, you don't really know how long it's going to last until you're done. Now, when we talk about activities with our parametric And with our definitive, we have to think about the type of work that we're doing. Is it effort-driven or is it of fixed duration? An effort-driven task means we can apply more effort to get done faster. So effort-driven, we have a huge room that we have to paint, like a ballroom at a hotel, a big conference room at a hotel. So if we have 2 people to go in and paint that room, it might take them a whole week to paint this huge ballroom. But can we put 10 people in there and get done in a couple of days? That's effort driven. That as we apply more effort, the duration of that task is reduced. That's also known as crashing. That when we crash the project, we're adding cost. When we crash the project, we add more labor. We have to pay for the labor. That cost generally goes up. So then you get into the conversation of, well, what's more important, time or money? So how firm is that deadline? If you want to hit that deadline, and these are effort-driven activities, let's crash it. Another approach we can do is called fast tracking. Let's go back to that ballroom at the hotel. And in this ballroom at the hotel that we have to paint, it's massive. Well, first, we have to prime the walls. And maybe this is in Florida in the summertime. It's very humid here in Florida in the summertime. And it takes longer for that primer to cure before you can start painting. So you're going to send a team in to paint the entire room, and then it has to wait, it has to cure overnight. And then once they're done with all of the priming, then we can begin painting over those walls. What fast tracking does is I don't have to have every inch of this room primed, that I have to have maybe one wall primed. And then we can come behind that and begin painting. So this would represent, let's say this represents the priming activity of that hotel ballroom. And as they prime, we have the painters coming behind the priming activity. So we aren't waiting for the entire ballroom to be primed. We're waiting for enough of it to be done and cured that we can begin painting. However, when we fast track, there is risk added to that possibility. Because remember, this primer has to be cured 100%. And if we prime the whole room and then waited, we know that risk would be gone of the primer being cured. If we allow it to overlap, maybe the painters haven't really allowed all of that to be cured, or they're moving faster than the priming crew, or there's a mistake made with the priming or the painting. So there's all sorts of risk that can be introduced when you allow phases or activities to overlap. That's called fast tracking. Then we think about fixed duration. Fixed duration is the concept that you cannot add more labor to reduce the duration of an activity. So, for example, we have a printing press, and we're going to print some brochures. By adding 3 or 4 pressmen to stand around and watch this piece of equipment work will not make that piece of equipment go faster. If you're in IT, you know often the more people that stand around and watch the install of a server or a piece of equipment, it often takes longer because everybody has a different idea of how to do it. Okay. So fixed duration means you can't add more labor. It's going to take this long to do this activity just by the nature of the work. You're limited to how the nature of the work, how quickly the equipment can go or the people can go. The equipment can only work so quickly. That paint is going to take so long to dry regardless. Then when it comes to unreasonable deadlines, we always come back to this idea of the equilateral triangle in Euclid. If you remember your Euclid geometrics there from high school, that all sides of an equilateral triangle are equal. And so in this equilateral triangle, on each side, we have time, we have cost, and we have scope. If my scope is this big, this angle and this angle have to be the same in proportion to my scope. I have to have enough money and enough time to create this thing. So if you want to reduce the amount of time, my options are to add more money, to get more labor, assuming it's effort driven, or we reduce the scope. We prioritize and trim the scope to make it fit the amount of time that we have available. Now, when it comes to, this is an unreasonable deadline, we take that proof, we take that evidence to the decision makers, and there are 5 things that could happen. The first one is they agree with the evidence that you have, this is unreasonable, and they allot more time to the project. They move the deadline out. Or what I was just talking about, they agree and we trim the scope to fit the amount of time that we have available. Or they agree, yep, it's unreasonable, but too bad, make it happen. Not a good result. Or they disagree, but nope, I don't agree with you, you can get this done. Or they disagree and they add more things to scope, which is probably the worst outcome, but it could happen. So when we go with evidence of things being unreasonable, those are outcome. We can agree or they can disagree. If they disagree, what do we do about that if they disagree? Then we know we have a risk. We document the risk, that deadline is unreasonable and there's a risk in this project that is a threat to meeting the objectives, to meeting our business value in the project. We have to be cautious here. We don't want this risk to become a self-fulfilling prophecy. We want to say this is a risk, this is a valid risk, and here's the evidence for it. That I just don't ignore it and we just march into oblivion here. That we document that risk. We document the probability and the impact. That we're saying we think this is a risk. Now we're not working to make that risk happen. We still have to manage the risk. Then we perform our qualitative and quantitative analysis. We have to qualify the risk through qualitative, and then we quantify the risk. So what is the effect on our project if we miss that deadline? What will that do to the project? Is it wrecked? Do we get some business value? So what's the probability and the impact? That gives us a risk score, or expected monetary value. Then, being a good project manager, we have to develop the risk strategy. So do we accept it? We just have to live with it and do our best to move towards that deadline and get as much done as we reasonably can. Can we mitigate it somehow? So can we mitigate that risk of the deadline? Can we avoid it? Like we have that ongoing discussion that we're moving towards this unreasonable deadline, or can we transfer it? That I want out of this project, I can see it coming a mile away, it's doomed, so I want somebody else to manage it. Can I transfer it? Well, none of those options may be good. So this all comes down to, if you have an unreasonable deadline, of proving its unreasonableness or learning that it could be okay. And then we can work towards managing that deadline or having to live with the consequences of working towards that unreasonableness in the project. So maybe not the answer you were hoping for, but hopefully it's some answers that you've received. I want to thank you for your time and attention. And if you have an idea on how to work towards an unreasonable deadline, something that you've used in your experience as a project manager, share that in the comments. Let other people know what's worked for you. I think that's one of the great things that we have now with technology, is we can quickly learn from each other's. So I'd love to hear what worked for you, or how you experienced an unreasonable deadline and what happened. Thanks again for watching. If you haven't already, give me a thumbs up and subscribe to this channel so I can continue to share great videos like this with you. Keep moving forward.